Hello everyone, welcome back to this channel. I'm Aishwarya Sothe and here we are going with the data structure series. Last video we have seen the searching algorithm as well as sorting algorithm. Today in this video we're going to cover the stack and queue data structure. So let's begin with the stack data structure. So stack is a linear dynamic data structure. Um, means I have already explained these means the stack is a linear dynamic data structure in my previous videos. If you didn't watch my videos, please go there and watch that video. So stack is a linear data structure and it follows LIFO. LIFO means last in first out, means whatever element or whichever element is inserted lastly or last whatever the element is inserted at last, that will be removed first. Okay, so that's actually the principle. And the stack has only one end. From that end only we can insert or remove the element from the stack. That element is called as top element, sorry, top pointer. Okay, so for better understanding here I have given you the one example. So here you can see that we can only insert the element from one end, that is per end. Okay, means two is one is already there, right? So two is inserted above one, three is inserted above two. Okay, right, that way. And at last five is inserted at four, above four. Okay, so if suppose I wanted to remove the elements, so first I need to remove 5 from the stack because it's the principle of the stack, that is last in first out. Means as a 5 is added lastly and um, means it should be removed first. Okay, so these are the operations or functions, you can say that. So first one is a push. So when we insert an element in a stack, then the operation is known as push. Okay, and if the stack is full, then the overflow condition occurs. And next one is the pop. When we delete an element from the stack, then the operation is known as pop. If the stack is empty, means that no element exists in the stack. This state is known as underflow state. Now, what is the overflow and underflow? I'll explain you with the example. Now, suppose this is our stack and this is empty. Okay, and uh, although it's empty, but you still removing the element from this stack. So this condition is nothing but the underflow. Okay, so that's it state that if the stack is empty, means that is no element exists in the stack, and still you are popping that particular popping the element from the stack, then it is called as underflow. And if this stack is filled up with means it reaches its higher state, means it is full, means it's having the means its blocks have means its block having the full of elements, means there is no such a space to insert more, and still you are inserting new one, then this condition is overflow, right? If the stack is full, then the overflow condition occurs. Okay, and is empty is nothing but simply whether the stack is empty or not. Is full is nothing but that particular stack is full or not. Pick means nothing but returns the element at the given position. If suppose means it's similar kind of like, if suppose we can say that by using the array index, uh, we are getting that particular element from the index, right? So according to that, means similar kind of work is the pick, right? So count means it's return the total number of elements are available. Change is nothing but the what changes, means is it change that particular element or particular position happens or not. Display means print all the elements in the stack available in the stack. Okay, this is the example of push and pop operation. Okay, so initially our stack is empty and top is initialized as -1. Okay, and we want to insert the element 10 into the top. Then as I told you that before inserting or before pushing the element, we need to increment our top. So we need to increment our top. So as before top is -1, after incrementing the top will be 0. Okay, and we will insert our element into the stack. Okay, after that we need to insert the 20. Again we need to first increment the top, that is top 1, top is equals to 1, and after that we can insert above the 10. Okay, in the same way that we can insert after this stack capacity exceed, then it will be giving the message like that stack is full, and after that you can't able to insert that particular or we can say that push the stack, because it states stack overflow, right? And coming to this part, that is uh, pop operation, means it shows the pop operations. So assume that the stack is full and we need to decrement, or we need to removing, or we need to pop the items or pop the elements from the stack. So so we need to first remove the element and then we need to decrement the top pointer from 1 or by 1. Okay, so here if suppose I want to remove the element 40 from the stack. So first what I will do, I'll remove this 40 from the stack, and then just I'll decrement this top pointer by 1. Okay, so as the top pointer is 2, after that it will be 1, and 30 will be means top pointer pointing to the 30. Okay, so in that way I'll popping out the element. After popping out all the elements, my stack will be empty at the last. Okay, so if suppose although my stack is empty and still I'm um, removing the elements, then this condition is nothing but the underflow. So these are the stack algorithm. So let's see the is full. As the name suggests, is full means if that particular stack is full um or not, means if it is a full, means it that particular top reaches the max size of that particular stack or not. If it is true, then it is returned true, otherwise it returns false. The same condition or same logic applies is empty function. Okay, means that particular uh, top or top pointer is less than 1. If it is true, then it's return true, otherwise returns false. Now push operation. So first of all we need to check whether the stack is full. As I've told you that regarding the overflow function, means we cannot insert or push the more function when the stack is, sorry, more element when the stack is full. So because of that we need to check this condition. After, if it is not full, then we can push our element or push our items to that particular stack. So before inserting the element, we need to first increment the top pointer by 1, as I told you that. Okay, so after incrementing the top pointer, then we can add our data to the stack of top. Okay, then pop operation. So pop operation means before popping the element from the stack, so we need to first check whether the element is, sorry, whether the stack is already empty or not. If it is empty, then return null, because if we are popping the element from the empty stack, then it will produce the underflow condition. Okay, then if the stack is not empty, then we can remove the element from the stack, and we need to increment the top pointer by 1. And we this is actually optional, but we may or may not return the data. It depends on the user actually and operation you want to perform. Now queue data structure. So queue is also the linear dynamic data structure. and it uses the FIFO approach, that is first in first out, whereas the stack follows the LIFO, that is last in first out approach. Here the queue follows first in first approach. As well as the in the stack there is only one pointer or one end from where we are in means where we are inserting and removing the element, but here there are two ends, that is front end and rear end. From rear end we can enqueue or insert the element, and from front end we can remove or dequeue the element. So for better understanding this queue, you can also take the example of the queue of the people in the bookstore, or queue in the railway station for booking tickets, etc. So these are the operations or function, you can say that, uh, for implementing the queue data structure. So in queue is nothing but the adding or storing the data to the queue. It is similar with similar like the push operation in the stack. Okay. Now dequeue is nothing but removing the element from the queue, and it is similar like pop. Peak is also there in the stack, then is full and is empty is also there in the stack. Now we'll see the algorithm of the queue data structure, that is enqueue and dequeue. So first of all, same like the stack data structure, we need to first check whether the queue is full or not. If it is full, then state that it is overflow. If it is not full, then we can continue to inserting. So before inserting into that particular queue, we need to first increment our rear, as here the means in queue operation is done by rear end. Okay, and at the DQ side means we need to first check the queue is empty or not, right? So if it is empty, then state that it's underflow, and if it is not, then we need to remove the data from the front end. Okay, and we need to just increment the front pointer. Okay, so as here having the two different pointer, so we need to just maintain the two different pointer for enqueue and dequeue, because rear pointer is for enqueue insertion, front pointer is for dequeue deletion or removing. Okay, so there are four types of queue: simple queue, circular queue, priority queue, and double-ended queue, means it's also called as DQ. So let's see one by one. So simple queue means in this queue the insertion takes place from one end while the deletion occurs from another end. Means as of now we have seen the example of the simple queue only. And actually the major drawback of the using linear queue means or simple queue is that the insertion is done only from the rear end, right? And if the first three elements are deleted from the queue, so we cannot insert more element even though the space is available, because the insertion is done on from the rear end, but the space is available now because we have deleted the element from the front end. So this is actually drawback of the simple queue. So circular queue, the circular queue is similar to the linear queue or simple queue, except the last element of the queue is connected to the first element. Okay, so as shown in the figure, the last element is connected to the first element, and means it's also called as ring queue. And the drawback of the linear queue is overcome by here, because the empty space is available. Means empty space, if the empty space is available, then the this particular queue will be occupy that particular space of to for um, inserting the new element. Priority queue is a special type of queue data structure where each element has the particular priority. So according to that priority, we can insert or remove the element. Suppose some elements occurs with the same priority, they will be arranged according to the FIFO principle. So insertion in the priority queue take place based on the arrival, means at what time they are arriving. Like means same as like FIFO principle. So first thing, so while deletion in the priority queue based on the priority. Now DQ. DQ means double-ended queue. Means here the insertion and deletion can be done by both ends, either rear or front. Okay, so as you can see here, image here, that is we can insert from the rear as well as front end, or remove from the rear as well as front end. There are two types of DQ, that is input restricted DQ and output restricted DQ. Input restricted DQ means input is restricted by the rear end. Okay, and output restricted means output is restricted by front end. In the coming videos, we'll complete the linked list data structure, and as well as we can also see the programs or else algorithms on the linked list data structure. So do subscribe, comment, and share, and click on the bell icon for more updates. Thanks for watching.